Welcome dear students to the chemistry session. Today we are going to talk about organic chemistry. More precisely, the subtopic alcohol will be explained. The general formula for alcohol is CnH2n plus 1 OH, or it is also represented as ROH, where R stands for CnH2n plus 1. This is the alkyl group. The various members of alcohol are methanol, ethanol, propanol, butanol, etc., which form a series of saturated compounds which can be represented by the general formula given above, that is CnH2n plus 1 OH. Thus, it can be noted that methanol, ethanol, propanol, butanol, etc. are from the homologous series of alcohol. The general formula of alcohol is CnH2n plus 1 OH. From the general formula, the members of alcohol formula can be obtained. For example, the formula for methanol, when we substitute N by 1, it turns out to be CH3OH. And when we look at its structure, we have one carbon attached to 3 hydrogen atoms, and the carbon is attached to an OH group. The OH group represents the functional group of alcohol. When the value of N is substituted by 2, the formula of ethanol is obtained. The formula of ethanol is C2H5OH. Its structure contains 2 carbon atoms bonded with 1 bond. The first carbon is attached to 3 hydrogen atoms, and the second carbon is attached to 2 hydrogen atoms, and it has a third bond between the carbon and the OH group. That is a functional group of alcohol. When the value of N is substituted by 3, we obtain the formula of propanol. The formula of propanol is C3H7OH. In this case, we have 3 carbons. In between the 3 carbons, we have a single bond in between them. And the first carbon is attached to 3 hydrogen atoms. The second and the third carbon are attached with 2 hydrogen respectively, and the third carbon is attached to the functional group OH for alcohol. When the value of N is substituted by 4, this gives the formula for butanol. The formula for butanol is C4H9OH. In this case, you will see that butanol contains 4 carbons. In between the first and the second carbon, second and third carbon, and third and fourth carbon, there is a single bond. The first carbon atom is attached to 3 hydrogen atoms. Second, third, and fourth carbon are attached to two hydrogen atoms respectively, and the fourth carbon is equally attached to OH group, that is the hydroxy group or the functional group of alcohol. Manufacture of ethanol. Ethanol is manufactured by the catalytic addition of steam to ethene. Ethene is mixed with steam and passed over phosphoric 5 acid. The phosphoric 5 acid is used as a catalyst. This reaction occurs at a temperature of 300 degrees Celsius, where ethene reacts with steam to form ethanol. And you can see that the double bond in between the carbon atom in ethene is reduced to a single bond in between carbon atom to form ethanol. The first carbon is attached to the hydrogen atom from the steam, and the second carbon is attached to the OH group from the steam. Thus, when ethene reacts with steam in the presence of phosphoric 5 acid used as catalyst at a temperature of 300 degrees Celsius, ethanol is produced. And another way to manufacture ethanol is the fermentation process of sugar solution. Ethanol can be prepared by the fermentation of sugar solution. Yeast is added to sugar solution, which acts as a catalyst. It produces ethanol and carbon dioxide. Carbon dioxide is a byproduct of this reaction. After the mixture has been fermented, the yeast is removed by the filtration process. This enables us to reuse the yeast the ethanol is concentrated by the process of fractional distillation. The physical properties of ethanol. Ethanol is a colorless liquid with boiling point 78 degrees Celsius. It is miscible in water in all proportion. It has a burning taste. Uses of ethanol. It is used as a solvent for many organic compounds. It is used as fuel also. It is a major component of all alcoholic beverages like whiskey, wine, beer, etc. Chemical properties of ethanol. The chemical properties of ethanol are typical to that of the properties of alcohol. This means that all alcohol will react in a similar way. When ethanol is lighted in the presence of air, it burns with a blue flame. In this reaction, ethanol reacts with oxygen to produce carbon dioxide and water. The second chemical property of ethanol is that ethanol reacts with sodium and potassium to produce their respective ethoxide and hydrogen. Ethanol reacts with sodium to form sodium ethoxide and hydrogen. Ethanol reacts with potassium to produce potassium ethoxide and hydrogen. And another important chemical property of ethanol is that ethanol is oxidized in the presence of an oxidizing agent. Potassium permanganate 7 oxidizes ethanol to ethanoic acid and water. In fact, ethanoic acid can be manufactured from ethanol by its oxidation. Another way to oxidize ethanol to ethanoic acid is by warming it with acidified potassium dichromate 6. The ethanol is oxidized to ethanoic acid and water. Both of the reactions are oxidation reaction, where ethanol is being oxidized to ethanoic acid and water. Chemical properties of ethanol is that when ethanol is mixed with pure ethanoic acid in the presence of a small amount of concentrated sulfuric acid used as catalyst, in the presence of heat, ethyl ethanoate and water is produced. The compound ethyl ethanoate is an ester. This type of reaction is known as esterification reaction. Here, the ethanol reacts with the ethanoic acid in the presence of concentrated sulfuric acid. The hydrogen atom from the ethanol combines with the OH group from the ethanoic acid to produce ethyl ethanoate and water. I hope that you have get a clear picture about alcohol and its chemical properties. I hope to meet you in our next section. Until then, have a nice day.